Welcome back to the last little video for Unit 1. We are going to look at solving polynomial equations with degree higher than 2. So everything we've seen up to this point has been a quadratic equation, meaning it had degree 2. Now we are going to look at polynomials, but with a degree higher than 2. Let's start with this example here. We're still going to use the same techniques that we have been using, specifically factoring if we can. And we're going to see more of this as the semester progresses. But for here, what I look at first is that the GCF, the greatest common factor here, is 7x cubed. So I'm going to factor that out. 7x cubed times x squared minus 7 is equal to 0. And then, just like we did with factoring a quadratic, we can set these factors equal to 0 using the zero factor property. Well, this one's easy. You divide by 7, you still get 0. You cube root it, you still get 0. The only way this statement can be true is if x is 0. This one we're going to solve using our square root property. X equals plus or minus the square root of 7. So we have three solutions here. 0, square root of 7, negative square root of 7 for x. Now when I look at this and I see a polynomial of degree 5, I think, I really should have 5 solutions here with this polynomial equation, but the reason that we're not getting that higher degree, or the 5 solutions, we're only getting 3, is because we say this one has multiplicity equal to 3. This cube here basically means we get x equals 0 3 times. So if you count this 0 3 times, then you do have 5 solutions. All right, let's take a look at another polynomial equation. This is a cubic polynomial equation, and we're going to try again to factor. When I see 4 terms like that, I want to try factoring by grouping. First and most important thing on both of these equations, the one above and this one, set equal to 0, and here my equation is set equal to 0. I want that to be able to use factoring. So I'm going to group the first 2 terms together, and I'm going to group the next 2 terms together. Now notice I did a little something different there. Group and group. Notice my sign changed on that second 7 that I have there. The reason for that is when I add parentheses and I have a negative in front, it's like having a negative times that entire thing, right? So if you think about redistributing this negative redistributed to here would give me the positive that I started with. So I just have to be really careful with the signs there when there's a negative there. The way we do factoring by grouping is we factor out the GCF out of each group. So we take this first group, the greatest common factor is x squared, we factor that out. The second group, the greatest common factor is 7, so we factor that out. Now I notice that I have a new GCF. An important thing here is to recognize that this is a term now, and this is a term now, because those things are multiplied, right? The x squared is multiplied by that x minus 1 quantity. The 7 is multiplied by the x minus 1 quantity. So in those 2 terms, I have x x minus 1 is a common factor in both of those, so I factor it out. When I factor x minus 1 out of that first term, I have x squared. When I factor it out of here, I have minus 7, still equal to 0. And now I have factored this. We call this factoring by grouping. If you have not seen this or you don't remember this, this is kind of a prerequisite for this class. So if you haven't seen this or don't remember this, you can do a Google search, a YouTube search for factoring by grouping, and you'll get plenty of videos to watch if you're not sure. And again, we set the factors equal to 0. Here I get x equals 1. Here I get x squared equals 7. My pen tablet is not working super well tonight. I don't know what's going on. Oopsie. So then when I use my square root property, I get plus or minus the square root of 7. Again, that is purely coincidence. I did not mean to have the same solution here as on the previous example. X equals 1, x equals square root of 7, x equals negative square root of 7 are our three solutions for that cubic equation. All right, last example for this unit in this video is this one. This is of degree 4, a polynomial equation with the polynomial is degree 4. This is what we call an equation of the quadratic type. There's a couple of ways you can approach this. One thing that you can do is if you recognize that the exponent here, this 4, is double the exponent on this middle term, and here we have a constant, you can do a substitution by saying let u equal x squared. Well, if u is x squared, then u squared would be x to the 4th. That x to the 4th can be replaced by, or could be replaced by u squared. Then we'd have minus 3, x squared gets replaced by u, and then we have plus 2 equal to 0. So what's happening here is this x squared gets replaced by u. This x to the 4th gets replaced by u squared. Now we have an equation of the quadratic type. This factors x minus 2, I'm sorry, u minus 2 times u minus 1 will equal 0. That means u minus 2 is 0 or u minus 1 is 0. U equals 2 or u equals 1. Now an important thing here is that the original question did not ask me to find u, it asked me to find x. And so if u is equal to x squared, I need to replace that and solve to find x. My square root property tells me that I get x equals plus or minus root 2. Same thing here. X equals plus or minus the square root of 1, which is just 1. So now I have these four solutions. X equals the square root of 2, negative square root of 2, 1, and negative 1. Those are my four solutions. Some people don't really like to do this substitution, and that's okay. You can use a different technique where you just maybe recognize from the beginning that this will factor into x squared, and x squared is going to give you that x to the 4th if you were to FOIL that out. And then I also need the minus 2 and the minus 1 to give me positive 2. And then the OI part of FOIL is going to give me the negative 3x squared. And you get to the same point, basically, right? You get to x squared minus 2 equals 0, so x squared equals 2, and then your work is the same from there. X squared minus 1 equals 0, x squared equals 1, and you get to the same solutions there. when you square root both sides of that. So whichever way you prefer to do it, it doesn't matter. Some people really like the substitution so you can exactly see that quadratic equation. But you don't, it's not necessary to do that. You don't have to bring that u in. You can stay in terms of x. So that is it for these sort of higher degree. These are some common ways you can deal with these. Notice all of them still involve the factoring technique though. And you could, like with this one, for example, it may not factor. And when you get to this point, you may have to use the quadratic formula or completing the square. There are options there once you get to that appropriate substitution. It doesn't always work out as nicely as this one did. One other thing I should mention about the previous one here, this, when we're talking about things not always working out, well, factoring by grouping worked here because these matched. If those don't match, factoring by grouping does not work, and you have to do something else. And we're going to get into that a little bit later in this class. How do you deal with something that doesn't factor with any of the techniques that we know so far? So just hang tight for that. That's in a few units. Be sure to let me know if you have any questions.